You know, some technologies feel like they've been around forever, right? They're so fundamental we just don't even think about changing them. And the chimney? That's a perfect example. But what if it could be more than just a pipe to get smoke out of your house? What if that chimney could be the actual heart of your home's energy system? Well, one company is doing exactly that. We're going to dive into a system that's designed to turn the humble chimney into an intelligent energy plant for your home. Let's see how they pull it off.
And that, right there, is the entire idea in a nutshell. It's taking this simple, incredibly wasteful act of just letting hot smoke float away and turning it into a huge opportunity to recycle energy you've already paid for.
Look, we're not talking about just a small upgrade here. This is a total shift in thinking. The whole point is to take a passive, kind of dumb structure and turn it into an active, intelligent part of your home's whole infrastructure.
And this comparison, it just lays it all out so clearly. On one side, you've got the chimney we all know. It's passive, it wastes a ton of heat, and it just pumps pollutants straight into the atmosphere. But then you look at the G2 system. It actively grabs that energy, it actually washes the exhaust clean before it ever gets outside, and the whole thing is managed by a smart system. It's a complete reinvention.
Okay, so how does it really work? Let's actually follow the journey of the smoke and the heat, starting with the very first and maybe the most important job, grabbing all that valuable heat before it can get away.
What's so cool here is this original sketch. You can almost see the gears turning in the inventor's head, mapping out these winding copper coils. It's a lot like the radiator in your car, really. The huge surface area of all these tubes is the absolute key. As that hot exhaust gets pushed through, the copper, which is superconductive, literally just pulls the heat right out of the smoke.
And yeah, there's a name for this whole process. It's called smoke heating. This is the foundation of the entire technology. So instead of just letting all that good heat drift away, the system actively strips it out and gets it ready to be used again, right back inside the house.
And you know what else is really smart about this design? It's flexible. It's not stuck with just one kind of fuel. The whole system is modular, so it can work with different heat sources. It could be a super efficient rocket stove, which, by the way, uses a really hot, insulated chamber to burn fuel almost completely, or a classic oil stove, or even a big cast iron heating chamber.
Okay, so we've got the heat captured. That's awesome. But that's only half the story, right? What about the smoke itself? You know, the stuff full of soot and all kinds of particulates? Let's move on to the next stage, because this is where the system gets really serious about being environmentally responsible.
Yeah, that's the big question, isn't it? If you're trapping everything, you've got to deal with all the byproducts. And this system doesn't just push them out a different pipe. It actually processes them.
The answer is this thing right here, the J2 smoke condensation chamber. You can see all the key parts in this detailed drawing. Now, I know it looks a little complicated, but the way it works is actually super clever, and it combines a couple of different physical principles to literally scrub the air clean. So here's how it goes down. First up, in step 1, you have these static electricity plates that act like a really powerful magnet, just pulling all the dust and soot particles right out of the air. Then, step 2, a superfine water spray creates this little mini rainstorm inside the chamber. This makes those particles that were just captured mix with water droplets. And finally, in step 3, that dirty water, now full of particulates, just falls down into a collection tray where it can be safely drained away.
So, we've got the hardware down for capturing heat and cleaning the smoke, but what's the brain of the operation? What makes it an active system instead of just a bunch of pipes? Well, that's where the intelligence comes in.
So, check this out. On the left, you see the system's components. Then, on the right, you see the exact same system, but with one key addition, the AI core. This is the central nervous system. It plugs into every single module, constantly gathering data and making tiny adjustments in real time. This is what takes it from a collection of cool parts to a genuinely smart network.
And the AI core is basically juggling 3 main jobs all the time. First, it controls the heat capture, tweaking fan speeds to make sure it's trapping energy as efficiently as possible. Second, it manages how that captured heat gets used, like say sending hot water to your underfloor heating system. And finally, it handles all the power management for the entire system, making sure every component gets the juice it needs.
All right, now that we've seen how it works on the inside, let's kind of zoom out and look at the big picture, the actual physical structure. A great idea is only great if you can actually use it in the real world, and that's where being modular is so important.
And this diagram just shows you how adaptable this thing is. Because it's built in modules, you can customize the chimney's height for pretty much any building. And get this? Look over here on the right.
It's even designed so it can be shared between two houses, like a duplex. One single system can heat two homes, splitting that captured energy between them. How cool is that?
And just in case you're thinking this is all just a cool idea on paper, let's peek under the hood at the actual engineering. This table is right out of the technical manual, and it shows you just how serious they are about the specs. We're talking a minimum of 3mm thick steel for the frames, a max height of 15 meters, and, this is critical, a zero-tilt alignment. These aren't just suggestions, they're hard limits to make sure the thing is safe and runs perfectly.
And I love this quote from the manual because it just nails this idea of precision. The system isn't something you just bolt onto the side of a building. It's designed to become an actual integrated part of the wall's structure. That's what ensures stability and helps spread the heat evenly. It's a totally holistic way of thinking about design.
So this is where we'll leave it. The G2 HTS proves that even the oldest, most overlooked parts of our homes are just waiting to be reinvented. And it really makes you wonder, doesn't it? If a simple chimney can be turned into a smart energy plant, what other incredible potential is just sitting there, hidden right inside our own walls?